All right, welcome to the video. I am about to complete the Unit 3 entirety test. I'm going to start with the FRQ, and I might not make it all the way through the test in this video just because it's getting a little late. I'm trying to wind down. But yeah, so I might do every problem, I might not. I'm going to see if I can keep it under an hour. If so, then I'm good to go. If for some reason it takes longer, then I'm probably going to bail. But with that said, let's start, shall we? So I'm going to look at this FRQ. This FRQ was the toughest part of the test for everyone. It was obvious, so I want to take my time here and solve these and explain along the way. So I am setting g equal to 1 plus root 3. So I'm taking the function and setting it equal to 1 plus root 3, and we're trying to solve for the values of x. So to start here, I need to subtract 1. And I'm just left with root 3. I need to divide by 2. And I'm left with cosine of pi over 3x equals, divided by negative 2, excuse me, negative root 3 over 2. So in this moment, you're asking yourself, when does cosine equal negative root 3 over 2? Cosine equals negative root 3 over 2 on multiple occasions, but the two occasions that occur in the unit circle are what? Option 1 is 5 pi over 6, so that means pi over 3 needs to equal 5 pi over 6. I'll write it over here. Yes. If the inside of cosine, this is the part that I think right here is where I lose a lot of you. I lose a lot of you when I make this decision, because it doesn't really feel, we're not canceling out cosine. That's because this is more sophisticated of a question, okay? It's not just magically going away. It's a little more sophisticated because cosine equals negative root 3 over 2 on multiple occasions, right? We can't just cancel away cosine and ta-da, here's the answer, right? Like, cosine equals negative root 3 over 2 over and over and over as we wrap around the unit circle, and we need those two main occurrences from the unit circle. That's where we need to start. So when does cosine equal negative root 3 over 2? This thing that I am describing here needs to equal 5 pi over 6, or it could equal 7 pi over 6. So that's our OR situation, and so far we're off to a great start. Okay? If I can get this to equal 5 pi over 6, this will be true. If I can get this to equal 7 pi over 6, this will be true. So let's make it equal 5 pi over 6. Let's solve the rest of the way with a times 3 and a divide by pi. That is reducible to 5/2. Let's do the exact same thing here. I'm going to do it in one swoop with a times 3 over pi. Pi's cancel, the 3's cancel, and I'm left with 7/2. So those are two solutions to this equation. But we want to find the values of x in the interval -4 to 4. Mind you, that's the same thing as -8 over 2 and +8 over 2. So are these the only two answers that fit in the interval? As this function wiggles along, it's going to equal negative root 3 over 2 over and over and over. But are there a couple more occasions? 2, 3, 4? Let's find them. Yes, there are. What is the period of this function? Let's go back to the equation. What's the period? 2 pi divided by b, which would be 2 pi times 3 over pi. The pi's cancel, and I'm left with 6, or 12 over 2. So if I add the period to 5/2, I will find the next time this answer repeats. That's a core idea of periodic functions. If this is one solution, this solution will show up again 1 period later. So what's 5 halves plus 12 halves? Certainly bigger than 8 halves. So adding is not finding me another answer. What's 7 halves plus 12 halves? Certainly bigger than 8 halves. It's not finding me another answer. What's 5 halves minus 12 halves? Negative 7 halves. That fits. So there's another answer. What's 7 halves minus 12 halves? That's negative 5 halves. That fits. That's another answer. Can I subtract again? No, that'd give me negative 19. Can I subtract again? No, that would give me negative 17. These are the 4 solutions that fit within the interval. Here, we're trying to figure out when does this cotangent function equal 0? When does this cotangent function equal 0? Well, let's get rid of the 5/7 by multiplying by 7/5, which really just doesn't even matter, right? Because that still does 0. Okay, so there's that. So when does cotangent equal 0? What is cotangent? Cotangent is the same thing as cosine over sine. Okay, so this equation is actually the same thing as 5/7 cosine of x plus pi over 2 over sine of x plus pi over 2, and we're setting it equal to 0. This canceled out, right? And so this equation right here is really the same thing as this. Why am I taking the time to say this? Why am I taking the time to say this? Well, please tell me, when is this fraction equal to 0? When is a fraction equal to 0? When the numerator is 0. If the numerator is 0, it doesn't matter what the denominator is. 0 divided by anything is 0. Well, anything except for 0, right? 0 divided by 0 would give you no solution. But cosine and sine are not 0 at the same time. We know that because of our basic understanding of the unit circle. They are not equal to 0 at the same time. So when asking ourselves when is cotangent equal to 0 is really the same thing as asking ourselves when is cosine equal to 0. It's actually the same question. Now, if you just have the values of cotangent memorized, well, then that's great, right? But I know there's a lot of you who don't, and I just don't know if it's 100% necessary to fully spend time. I just don't know if it is necessary to memorize the cotangent values perfectly. But it is necessary to understand what cotangent is. So, when is cotangent equal to 0? When cosine is equal to 0. And when is cosine is equal to 0? What does this need to be? What are our options? Cosine is equal to 0. What are the 2 moments on the unit circle? It's equal to 0 at pi over 2, or it's equal to 0 at 3 pi over 2. Yeah? So this solution, subtract the pi over 2 and you get 0. Subtract the pi over 2 and you get 2 pi over 2, which would be pi. So those are 2 of the infinitely many solutions. Are there any more that fit on the interval 0 to 2 pi? Well, what is the period of cosine? 2 pi. Did we change it? No, because the b value is 1. So add 2 pi to 0 and you get 2 pi, which is within the interval. So there's a third solution. Add 2 pi to pi and you get 3 pi, which is outside of the interval. So there are 3 solutions here. Okay. Watch it back. Watch it back again. Watch it back again. Graph it. Really believe that these are the answers. Really believe that those are the answers. I made that 2 look like a 3. Really believe that these are the answers. All right. Rewrite J as an expression involving tangent and no other trig functions. Well, tangent is sine over cosine. So somehow we're going to end up with a sine over cosine. Well, 1 minus cosine squared is just screaming at me because I know that sine squared plus cosine squared equals 1. So if you just subtract the cosine squared to the other side, we're suddenly realizing that sine squared is equal to 1 minus cosine squared. So immediately, I can turn that numerator into sine squared. And OMG, I have not sine over cosine, but instead sine squared over cosine squared, which is, I think, pretty obviously tangent squared. Great. That one wasn't too bad. Actually, quite a few people got that right. A lot of people just wrote tangent, though, which I was a little like, well, why'd you get rid of the squared? Sine over cosine is tangent. But if both things are being squared, the squared didn't just disappear. Okay. Rewrite k of x as an expression involving secant and no other trig functions. This was a bit more challenging, and I saw quite a few different tactics. Now, the tactic that I see here is I have a fraction, and, you know, basic fraction facts, people. A plus b divided by c is the same thing as a over c plus b over c, right? That's basic fraction fact. So that means this is a, this is b, this is c. That means this fraction is equal to this. Now, what's giving it away that I want to do this? Nothing particularly is giving it away, but I kind of liked that, cotangent divided by cotangent is 1. I see that, and I'm like, I like that. I like that that's going to make 1. That feels nice. Now, what's tangent divided by cotangent? Well, dividing by cotangent is the same thing as multiplying by tangent. Dividing by cotangent is the same thing as multiplying by tangent. And that's a basic fact that we need to realize because tangent and cotangent are reciprocals. Dividing by tangent gives you cotangent, and thus dividing by cotangent gives you tangent. So tangent times tangent is tangent squared. Gasp! 1 plus tangent squared is secant squared. Boom. Now, didn't have that one memorized, 1 plus tangent squared? Well, I suggested to every class period at the beginning, like, hey, we all know sine squared plus cosine squared. Well, you can divide by cosine squared. And as you divide by cosine squared, you get tangent squared plus 1 equals secant squared. Aha! Yes, it does. Suddenly, we have secant squared. All right, one more. Find all, I even emphasized it with italics, input values in the domain of n that yield an output value of 3 root 3. So when does this function equal 3 root 3? All you got to do is divide by 6 here in that first step, and the 3 is reduced to be, or the 3 and the 6 reduced to be a half. So when does sine equal root 3 over 2? Here we are in that classic moment, right? Again, this is the moment like that so many of us are perturbed by. Sine of, right? This sine of yada yada needs to equal root 3 over 2. Well, when does sine typically equal root 3 over 2? When does it typically equal root 3 over 2? For the angles pi over 3 and 2 pi over 3. So, logically speaking then, if we can just make the yada yada equal pi over 3, then that will make this true. Right? We know with absolute certainty that sine of pi over 3 is root 3 over 2. So if we can make, 1/2 times something needs to equal pi over 3, right? X is not simply pi over 3 because it's being multiplied by a half. A half times x needs to give us pi over 3. 1/2 times x needs to give us 2 pi over 3. If we can make that happen, then we will have found the solution. If we can make that happen, we will have found the solution. So multiply by 2 here, and you get 2 pi over 3, excuse me. And when you multiply by 2 here, you get 4 pi over 3. And that was the first point of this question. By the way, all the problems prior to this were just 1 point if you got the answer, if you didn't get the answer. That's the first point of this question, 2 pi over 3 and 4 pi over 3. So now we want to write out all of the solutions, okay? We want to write out all of the solutions. So this answer is going to repeat every period. Well, what's the period? Well, we need to consult the function, look at that b value, and realize 2 pi divided by a half is 4 pi. So 2 pi over 3 plus 4 pi k will find all of those solutions. But this answer will also repeat itself every period as well. Okay. How was it? Go back, watch it again. Did that in 17 minutes. Perfect, perfect, perfect. All right, let's look at the non-calculator. So I'm going to tell you what the ideal answer is, and then I'm going to tell you what everybody else did. So I gave what everybody else did points because I understand it, but I need you to realize that distance is something that is never negative. So I'm going to do this problem the perfect way, but I'm going to let you know that basically everybody wrote -10, -18, and -26. And that's because I have made there have been I didn't make all the problems, but there have been problems where something was going back and forth, above and below, or to side to side, and we used positive to mean above and negative to mean below. But this blade is always, this motor is always below the water. That's never a question. And so here, this was a question about distance. So the distance, right, there are kind of a few key moments. I'm going to do like a little triangle thing like this to be the blade, okay? There's this moment when we're closest to the water. So the distance is the smallest it will be. There's this moment when it's halfway down. And that's when the distance is at the midline. And there's this moment when the point is furthest away. So this, when the blade is at the, which is a bit of a weird thought, right? When the point is at the bottom, the distance is at its largest. And when the point is at the top, the distance is at its smallest. So when they told us point B is 8 inches from the center of the motor, we're learning that this is 8. The center of the motor is 18 inches below the water line. So that means this little gap here is 10. And then there would be another 8 to get to the bottom, which would be a total of 26. 18 plus 8 is 26. So when we're at the when B is at the top, the distance is 10. When B is in the middle, the distance is 18. When B is at the bottom, the distance is 26. And so this is 26. This is 18. and this is 10, not negative 10, negative 18, negative 26. It's actually 26, 18, and 10. The blades of a boat are rotating in a clockwise direction and complete 50 rotations every second. We'll come back to that in a second. Point B is on the tip of the blade, right? You already read the problems. That's why I'm just speed running here. Point B is 8 inches. And so, but okay, right here. Point B is on the tip of the blades and is located directly above the center at t equals 0. So t equals 0 is when B is at the top, which sounds like maximum. But if B is at the top, the distance is at its smallest. So J here is t equals 0. I know that's breaking your brain a little bit. I know it is. I know that's breaking your brain a little bit. You're like, B's the top. Yes, but when B is at the top, the distance up to the water line is at its smallest, which is a minimum. Okay. So F will have a Y value of 26. G will have a H value of 18. This will have an H value of 18, and this will be back to 26. So how do we spread out the time here? Now, you might be thinking, well, if this is 0, isn't this going to be negative time? Yes, that's true. If you don't like that, then don't make that 0. If that bothers you, continue this backwards in time and make this over here 0. That's okay. That's okay. That's okay. Would you prefer that? That's what I'm going to do. So 50 rotations every second, 50 complete rotations in one singular second, we go around 50 times. That means one singular rotation is simply a 50th of a second. So this is our period. We complete one rotation of the motor in a 50th of a second. And then we need to take that 50th and split it into fourths so that way we know how to step upwards. So every point here is 1/200th. That's how you pronounce that. 1/200th of a second. So if this is 0, this is 1/200th, 2/200ths, 3/200ths, 4/200ths, 5/200ths, 6/200ths. You do not need to reduce for the sake of this point, okay? The function h can be written in the form blah. Find the values of the constants. So if you believe these numbers, A and D come pretty easily, D being our midline, and we're going up a distance of 8. That's pretty straightforward there. But B and D, of course, always being, or B and C, always being the tougher part. If the period we've established is 1/50th, we do 2 pi divided by a 50th to find B, which is 2 pi times 50 over 1, right? To divide by a fraction is to multiply by its reciprocal, and you get 100 pi is the value of B. And then finally, C, I've said it before and I'll say it again, sine, quote, starts at the midline, and cosine, quote, starts at a maximum. So I actually already labeled this as 1/100th. So that could be the start of sine. So minus 1/100th would be correct. But also, this is the start of a sine curve. So also minus 5/200ths would be correct. Both of those are reasonable responses. Why are we negative though? Because if this is 0, the function has been moved right, no matter how you cut it. Now, because I have made this decision that all of the distances are positive, these negative options no longer make sense. Again, many of you having done -10, -18. I didn't count that against you, okay? I really truly didn't, okay? I really truly didn't. So positive and increasing or positive and decreasing? From F to G, we are decreasing. Simply option 2. On the interval T1 to T2, describe the concavity. Okay, that same interval, T1, the graph of H is concave down on T1 to T2. Describe the concavity? Check. Therefore, determine the rate, how the rate of change is behaving. Rate of change of H is decreasing. Concave down means rate of change is decreasing. Case closed. All right. It's only been 25 minutes. Knocked out those 2 FRQs. Let's go and see what we can do with the multiple choice. Again, I'd like to stop. I'm gonna stop in 20 minutes, so we'll see how far we get. How about I go in order of most missed? How about that? It's probably a good way to keep this video as valuable as possible. Number 11. Number 11, really? Okay, so the graph of cosine is invertible if the domain is restricted to what? Well, you may have just, you should have just memorized the restriction for inverse sine is from negative pi over 2 to pi over 2. The restriction for inverse tangent is the same, negative pi over 2 to pi over 2. And the restriction for inverse cosine is 0 to pi b. Now, even if you didn't have that memorized, which you should, the graph of cosine looks like this, right? Let's do 2 periods, right? It looks like this. So remember, our lengthy discussion was like finding a chunk of the graph that does not, the quick observation was like restrict it to a piece where none of the outputs repeat, right? So that way it's invertible. So this piece from 0 to pi, right? It passes, casually speaking, the horizontal line test. If I were to restrict it for this answer, which is wrong, from negative pi to pi, well, that doesn't pass the horizontal line test. And either does negative pi over 2 to pi over 2, and either does 0 to 2 pi, right? So if you did draw a sketch, that invertibility test is something that we spent, a whole class period on. But really, this question was just, did you memorize these little restrictions? And it appears you did not. Okay, number 8. Okay, considering, okay, I'm a little upset here about this one, but wait. Oh, this is version C. Oh, this is version C. Ah. That wasn't okay. I bet you guys did memorize this. I don't mean to be giving you a hard time. Oh no, I downloaded version C. Okay. Off screen here. I'm going to open up. Oh, you didn't see that. Off screen here. I'm going to open up. Actually, I'm going to pause this video. Okay. So, question, back to in order of most missed. Question 11 was this one. Okay? So, the trig identity, okay, let me pull up one other thing. The trig identity that was on the list of documents. Do I have it handy here? Here we go. Was this guy right here. And so, again, I told you, if you don't memorize it, you're going to get it wrong. If you do memorize it, you're going to get it right, basically. So the sum and difference. So what format are we looking at? We're looking at cos, cos, sine, sine. Aha. That is the cosine sum and difference. And if it's a plus sign, you're subtracting the two angles. So this is matching. Can you see my mouse circling? Oh, you can't see this. It's a little off screen. There we go. Is matching this guy, right? Because we're adding cosine, cosine, sine, sine. Alpha, beta, alpha, beta. So we're going to subtract alpha and beta. This is alpha, this is beta. This is alpha, this is beta. So all of this is equal to cosine of alpha minus beta. All of this is equal to cosine of 3x minus 2x. All of this is equal to cosine of x. Like I said, if you memorize it, you get it. If not, you don't. All right. Number 8. Oof. You know, I gave you, I did this problem and then I said, oh, I'm sorry that I gave you such a hard time. But then, number 8 was this question, inverses. Okay, so maybe I should give you a hard time. What is inverse sine of negative 1/2? Well, sine of what equals negative 1/2? Well, your brain might say 7 pi over 6. Your brain might say 11 pi over 6. And you're right. But inverse sine of negative 1/2 is neither of those angles. Inverse sine is restricted to pi over 2 to negative pi over 2. And 11 pi over 6 is kind of what we're looking for, except we need to express it as a negative angle to keep it within the restriction that we know inverse sine needs to be in. 11 pi over 6 is the same thing as negative pi over 6. And that's the answer. B. A lot of people choosing C. I'm sorry. A function can't have two answers, right? This can't have two answers. That's not how functions work. You can't plug something into seriously, if you can think of a situation where you plug a number in and get two answers, please present it to me. Let's have a discussion about it. I bet some of you are thinking square root, right? You're like, well, isn't that plus or minus? No. The square root function is this. The square root of 4 is 2, and 2 alone. The inverse sine of negative 1/2 is negative pi over 6 and negative pi over 6 alone. Number 7 on version A, which is problem 6 here. So, which of the following functions does not have vertical asymptotes at the values x equals pi over 4k, where k is any integer? Does not have vertical asymptotes. So that means 3 of these 4 functions do have vertical asymptotes at pi over 4k. What causes a vertical asymptote? Dividing by 0. So this is dividing by cosine. This one is also dividing by cosine. Okay. This one is dividing by sine. And this one is dividing by sine as well. Okay? So which of these is not so let me rephrase this. If we have a vertical asymptote at pi over 4k, that means when I plug pi over 4 in, I would get 0. because dividing by 0 gives me a vertical asymptote. So this very first one, if I plug in pi over 4, what do I get? Cosine of pi. What's cosine of pi? -1. Oh, I didn't get 0. Option A. Right? Now, believe it or not, I made it option A intentionally, hoping that you would do this and realize suddenly it was the right answer. Because if you start wasting your time with all the other ones, you start stressing you out, right? Like, simply put, you have a vertical asymptote when the denominator is 0. So just test it. Do you have a denominator of 0? No? Okay, does no vertical asymptote. Now, we could sit here and check all the other ones, but no, I don't want to. These, by the way, had the same denominator. You know what that means? They're either both wrong or they're both right. Now, not that it's not possible for me to make a typo, but not that bad of a typo. Okay? Not that bad of a typo. They're either both wrong or both right. I guess they must both be right. And by right, I mean not the correct answer. Right? Because we're looking for the one that doesn't work. All right. Number 12 is the cotangent with limits question. Okay. Two very related questions. Because why is there a limit of infinity in the first place? Because there's a vertical asymptote. Why is there a vertical asymptote? Because we're dividing by 0. So what is this function? 2 times cosine of x minus pi over 4 divided by sine of x minus pi over 4. So as you can see here, right, we have this denominator of sine of x minus pi over 4. And when does this equal 0? Well, sine of 0 is 0. And sine of pi is 0. So there's a vertical asymptote at pi over 4, and there's a vertical asymptote at 3 pi over 4. So you can see why these are appealing, okay? But there's also this negative pi over 4 situation as well. But if you were to plug in negative pi over 4, you would get negative pi over 4 minus pi over 4 would give you negative pi over 2. Sine of negative pi over 2 is not 0. So that this x value isn't even giving me a vertical asymptote. So that can't be right. Does that make sense? And now what about negative 3 pi over 4? Because negative 3 pi over 4 minus pi over 4 is negative 4 pi over 4. Sine of negative pi is 0. So I guess that's technically kind of in the running. But the question is, if we focus on these two, just for the sake of entertaining ourselves here, they're both pi over 4. This is saying on the left, graph go down. On the right, graph go down. Those can't both be true. You can't be going down on both the left and right. So it's got to be one or the other. Now, if you're good at if you have the basic graph of cotangent in your head, I've been yapping about solving, but the thing is if you just have the basic graph in your head, this function actually speeds up, or this question, excuse me, actually speeds up. Cotangent is a decreasing function like this, unless it were to get reflected with a -2 out in front. But it's not. It didn't get reflected. So it looks like this. So what we're saying is on the right-hand side of every asymptote, graph go up. And on the left-hand side of every asymptote, graph go down. On the left, graph go down, not on the right. On the left, graph go down. Okay? You feel me on that? Let's say that again. Oops. Let's say this again. This is the basic graph. Anytime there's a vertical asymptote for cotangent, It's descending downwards like this and approaching the other asymptote. To the right of the asymptote, graph go up. To the left of the asymptote, graph go down. To the right of the asymptote, graph go up. To the left of the asymptote, graph go down. To the right of the asymptote, graph go up. To the left of the asymptote, graph go down. To the right of the asymptote, graph go up. Oh, okay, I guess that was worth entertaining, but we understood that that wasn't an asymptote from solving. To the left of the asymptote, graph go down. Okay, I like it. To the left of the asymptote, graph go up. No, graph go down. To the right of the asymptote, graph go down. No, graph go up. It's got to be B. Number 9. The question about the rainforest. Where is it? Rainforest. Aha. For a rainforest, the number of inches of rain expected in a given month is modeled by R, where T is measured in months. Based on this model for 0 to 12, at what time T is the last time there will be 10 inches of rain? So we want to know, when does this function equal 10, and when's the last time it'll equal 10? So this is a solving problem. We want to know, when will this equal 10? When will it equal 10? Well, you're going to subtract the 12 and get -2. You're going to divide the 4 and get a -1/2. So then you're asking yourself, when does cosine equal -1/2? Well, it equals -1/2 for 2 pi over 3 or for 4 pi over 3. Which means T equals 3 cancels, pi's cancel, 2, or T equals 3's cancel, pi's cancel, 4. So at T equals 2 and at T equals 4. Is that 4 is an option? Am I right? Well, there's a lot more months to go. When do these answers repeat themselves? Every period. What is the period? 2 pi divided by b, the period is 6. So this answer will repeat itself at 8, not listed, and this answer will repeat itself at 10, listed. Is there another one? 8 plus the period would give me 14. No, that's gone. We're already past. So the last time that it happens on the given interval is at t equals 10. I have time for one more. I'm calling it here. The next most missed question was number 14. Which of the following expressions is not equivalent to sine? Which of the following expressions is not equivalent to sine? Well, if you take the graph of sine and move it left pi, that would be like that. Are those the same anymore? You might be like, you're like, bro, what? Let me set the scene a little bit better. This is 0, pi, 2 pi. We could keep going. And the curve continues, right? And this is 0, -pi, -2 pi. And if we take this function and move it left pi, is it equal to sine any longer? No. No, it's not. These aren't the same. Wrong. Also, like, if they're equivalent, that means, like, you know that sine of pi over 2 is 1, right? Well, if this is equivalent, then that means plugging in pi over 2 should also give me 1 for this. Pi over 2 plus pi is 3 pi over 2. Sine of 3 pi over 2 is negative 1. They did not give me equivalent answers, so therefore they are not equivalent. Boom. Which one is not equivalent? You know what I'm saying? So this is saying, what does the graph of cosine look like? It looks like this in pink, all right? And if I were to move it right pi over 2 is right here in the middle, right? If I were to move this function right pi over 2, which is what B is saying, right pi over 2 would, oops, let me grab them at the same time. Or can I? Right pi over 2, oh, now I'm grabbing the, right pi over 2, oh, right? I'm fixating on this point right here and watching it move to the right. Oh, to the right. Yeah? And suddenly it clicks into place. I mean, I think this demonstration is kind of the most bulletproof. It's like, okay, if they're equivalent, they should give me the same answer. So take something that you know to be true. Sine of pi over 2 is 1. Okay, plug pi over 2 into each of these. What's cosine of pi over 2 minus pi over 2? 0. Cosine of 0 is, oh, 1. Sweet. What's cosine of pi over 2 minus pi over 2? Oh, wait, that gives me cosine of 0 again, which is 1. Okay, what's negative sine of pi over 2 minus pi? Well, negative sine of pi over 2 minus pi is negative pi over 2. What's sine of negative pi over 2? That means I have to open downwards. Oh, that would give me negative 1. So what's negative of negative 1? Positive 1. Right? When I plugged pi over 2 into each of these, they all gave me 1 except for the one expression that's not equivalent. Now, these also are on the identities list, okay? Like we have spoken about option B at length, that sine and cosine are just a shift apart. We've spoken about B at length. We also brought up complementary angles. Now this one you might have to think about a little bit. This one's a little random. But again, I did make A the right answer, anticipating that you would go, wait, if I take the sine curve and only move it left pi, that's not far enough, right? If you move it left and right, the period, it's like nothing happened. But moving it left pi is only half a period. That's not far enough. If this said plus 2 pi, that would have been equivalent. If it said minus 4 pi, that would have been equivalent because it's a multiple of 2 pi. Adding pi, it's just not far enough. All right. It's been real.